Greetings all. We just wanted to jump on and do a quick video here today as I continue this sort of study as I'm working through this concept of the sun's rotation. So those that maybe watched the previous video that I did on the solstice, the day of the solstice, we went through and we were theorizing sort of this movement of the sun and how it must be happening in the layers of the atmosphere above. And so we have this idea of the most purified layer of the atmosphere above, which would be hydrogen and helium, atomic level. So when we think of Levitical law and everything sort of as you're ascending the mountain up here, everything would be getting more and more purified and closer to this sort of this meeting point that's happening between the crossing of these two pillars or these two planes. And so we think of this plane of the earth as being sort of this it's flat and level, and then we have all of these sort of stratified layers above the gases. And so the gaseous layers we got to be thinking as being flat and stratified as well, and then we're tenting into sort of those layers and then having this sort of crossing or meeting point and to start to ionize and produce some of these lamps, so to speak, or these lighted areas. So at any rate, we're thinking about how the sun is moving, and we basically understand it through a circle. So we know everything's moving in even circles. It's just the apparent motion that we end up seeing, it ends up being sort of distorted. And so when we find the analemma here by taking a snapshot of the sun every day over the course of the year, of course, we're taking it at, we could represent this as noontime. So if we were to take a snapshot of the sun at noontime every day over the course of the year, at exactly noon, this line would represent our noon time frame. And so the noon time on our watch, remember, is going to be sort of the mean, it's going to be the mean measure of time day by day. And so when we look at the equator right here, remember the equator, even though the sun is never at the center of this sort of this epicycle right here. So the radius of this, again, we had set at 61. We set the radius of the Earth here, this 90 degrees, at 233. We did this off the biblical numbers of 151,450 and 39,650 that we found in the first counting, the first census in numbers. But really, we reduced that by a factor of 650 in the last video. But really, we should probably only reduce it by a factor of 65, that number for Adonai, right? So if we were going to look at Gematria value, the number for Adonai, one of the names of the Lord, would be a value of 65. So if we reduce this by 65, this distance right here instead would be 2330, excuse me, and this distance, our radius right here, would be 610. And this would be better to, I think, to do, instead of 61, we can use 610, and we know that 610 is going to be our 15th Fibonacci number. So 233 is our 13th Fibonacci number. When we add 377, which is our next 14th Fibonacci number, we're going to get 610. So it would be better to use, I think, these clean Fibonacci numbers in representing these distances. So 610 instead of 61, and then we'll use 2330. And again, remember the mathematics when we did the, if you look at that formula that I used in that last video, I'm not going to pull it back up, but when this measure was 233, the measure to the center right here was 225. And so, of course, we would be dealing with 2250 again. And remember that 2250 was sort of when we added that to the 603550, again, that was that number that we found, that missing number for the Levites, because that gives us 605800. When we divide that by 4, we find the 1/4 part of Israel, which is 151,450, which is the grouping of Reuben, Simeon, and Gad together in the first census. So that's our 90-degree piece, our quarter of the circle. But so this would be called, we'd be calling this 2250 now, and this would give us a balance of 80 right here. And then so if you look at the astrolabe video I did, you'll know that the breakup of this 610, then you'd have to double this to get the total length of the analemma. And then of course these are going to be relative to phi as well, since this is the crossing happens at 90 degrees and this is 90 degrees, so 2330, this would be 233 then. And then because of the relationship of the analemma from the crossing to here, we know that this is a multiple of phi. So from our equator to the crossing would be 1, and we have a value of 233. That means 23 times phi. The golden mean is going to be 377, so this section would be 377. And then we have 220, no, this would be 80 minus 233. So 233 minus 80, again, is 153. So again, that's sort of that 153 number is people are going to look at that New Testament, and we find that in the number for Judah in the second census as well. But so 153, 80, we can start breaking these down into further sections. But at any rate, I got to thinking about this, and since we've got we're trying to find this center point, and so the crossing of these two circles, when we form the Pisces and find the center right here, we're going to get this value from the center right here to 250 now, with this value of 80 right here. And I got to thinking that if the sun's getting produced on an even level right here, we know that the degree of rotation right here off of the mean center of this has got to be equal. So I was wondering, at what point can we have an equal amount of rotation end up with arriving to this 47 1/8 degree of latitude here? So again, how we get that 47 1/8 degree, remember that 39,650. Well, we'll just do it like this. We know that that's relative to 23.5 degrees. So if we were to take 39,650 and divide it by 605,800, we get this value when we multiply this times 360 degrees. So we have a percentage here. By 360 degrees, we're going to get this value of 23.56223 degrees. And so this value is essentially the same as if we can clear this off. We're going to find phi, square root of 5, and then we're going to add 1 and divide by 2, and we're going to get this value. So this is our value for the golden mean, or phi. We're going to store this in our memory, and now we're going to take this and we're going to square this value to get 2.618 and multiply it by 9, and you see we're going to get the same value of 23.56. This is slightly off. I don't know what happened there, but anyway, 23. So we're very close to the numbers that we get in the biblical value of that Judah South portion. It gives us this value. Okay, so when we multiply this by 2 now, so remember that's only half the distance from our equator to our limit. So when we multiply this by 2, our actual range here is going to be this 47 1/8 degree. So we have a 47 1/8 degree for the total length here, which is 2 times phi squared times 9. So when we think about, if we're going to take that phi squared value back out of this, and remember we can do that because when we think of each one of these hands, right? Each one of these hands over here, when we think side to side, just like as we see in magnetism, which is sort of our way of seeing the light, we know that these are going to be phi to 1 side to side. And when we're crossing 2 of these together, we know that we have this value of phi squared, so to speak, from our one quadrant to the other. So it's fitting that we could reduce this value right here, our degree value of latitude. We can divide this by phi squared again and get back down to 18 degrees. So I was thinking that, okay, if we have 18 degrees and we know that the crossing right here happens at 9 degrees, so we're really getting pointed down this path of 18 degrees being significant. And so I was like, okay, well, I took this right here, and we're going to rotate this back to 0 degrees. And so I took two lines. And I made one 0 degrees, and then I inclined one 9 degrees to the right, one 9 degrees to the left to get my total range of 18 degrees. And then I had to extend the length of these towards the inside, and then I was able to rotate this to the point in which I could get this so that it lines up, so that my 18 degree range was going to fall at my solstices right here. So the limits that we have of our parent sun, of where it is, we can set that to, essentially we've got an even rotation of 9 degrees to either side of this mean point. And so, I was like, okay, well, what does that do for us as far as, a center point? Where is our actual center? And you see that our actual center is going to be happening right at that cross. So right where we find that sort of this sort of Pisces of the merging of these two circles is going to be the center of this rotation. When we set this up to an 18 degree rotation, 9 degrees to either side, that's going to give us a 9 degree crossing. Again, this is going to be our mean center of time measurement based off of distance is going to be right here, and then our mean center of distance altogether right here based off of a 24-hour day is going to be right here, our equator, or actually the mean distance of time over the course of the year, our tropical year. So, the actual center right here does seem to be the center right here of this Pisces, and this 9 degrees right here on either side. So this 9 seems significant, and so I had to rotate this 48 degrees off of upright, which was essentially off of our vertical plane. It's 42 degrees up. So 42 degrees, again, we're seeing that number of 42 degrees up, inclination to hit, and then I figured, okay, well, what's our distance right here? Again, our distance, if we're going to look at this circle right here, my width of this was going to be right at 26. Right at 26. So when I did the widths of all of these circles, I kind of aligned these to, 233, and then this one would be like 260. So essentially this distance then right here would be 2600. And again, we see this, 2600, when we're looking at, 233 times 2600. This is 2600 times the, this is how we get 605,800. So it's these numbers are popping up, and it's happening. There's too many coincidences here for this to try and not to think that this isn't probably how it's happening. So at any rate, I just was coming across some of these correlations, and you can go back and look at some of those other videos I did with sort of this idea of Ptolemy emerging, how this merges with an astrolabe. Astrolabe is obviously changing the latitudes. It's condensing the latitudes to make this circle more rational. The other thing would be to take on your globe model and understand like how lines of longitude on a globe are actually you're stretching that line of latitude, but or longitude, excuse me. But anybody that's done map to ground land navigation with a magnetic compass will know that your north isn't straight. So I mean, you've got to project how that would be happening, and if you can't shoot a straight and just follow your compass straight from your 0 degree latitude to 90, obviously you're making this big swooping path through here to get to the pole. So that distance has got to be it's got to come from someplace. And if you look at the equation for the surface area of a globe with a dimension, you're going to have a dimension for a equator right here. If you put that equator on a if you compress it down into a flat circle like we did here, you know, the circumference of a globe of this would be your equator. Well, the equator on a flat plane right here that's double, you know, essentially that would be half the distance of your radius. Your total radius would be twice the distance. Well, you know, you're going to take 4 times pi times radius squared to get the surface area of the sphere, but it's going to be 2 times radius squared to get the area of the circle. So, you know, if you think about it, you have the same surface area on the globe as you do a sort of a flat, a planar, circular landmass. You're going to have the same amount of surface area. You just got to think about how your lines of longitude, your north to south lines, are essentially bending on the flat projection. But at any rate, yeah, I just thought that was pretty interesting. Again, 42.5 degree incline right here to the center. That would give you 33, a range of 33 to 51 again. 51, you know, that's the index number for 233. It's the 51st, what do you call it there? Prime number. And then again, we did that with Kepler's law of cubing 51 and taking the square root to get your 361. Again, with your when we're measuring the distance on this analemma, remember the crossing to your limit here, straight line distance, the relativity is going to be, if this is 1, then this is the square root of 2. But when we're talking about the number of days it takes on this arc right here, remember this was 139 to 225. And so that's a relationship in days. It's going to be a relationship of the golden mean, but in the absolute distance, it's going to be, 1 to the square root of 5. So yeah, just a lot of interesting finds. And like I said, you can go back and look at the other videos and kind of see how all this ties in. But just thought I'd share that with everybody while it was fresh in my head, and hope you appreciate that. We'll see you on the next one.